Okay guys, so this is a very simple foldable on classifying triangles. Should not be a whole lot of new information here, but I want to make sure that you've got down what you should already know, and there may be a couple of new things in here that we point out so that we can move forward. And tomorrow we'll look at what that looks like on the coordinate plane and some other different questions that go a little bit further than this. Okay, so this is the basics of triangles. And triangles can be classified in two ways. I can classify them by their sides, and those are equilateral, scalene, or isosceles. Or I can classify them by their angles, which is right, acute, and obtuse. Okay, so this is the back side of the foldable. If you will fold it up, and then we're going to look on the inside. And on the inside, when I do that, I will see it will look like this. All right, so we've got right here on my left-hand side, these are by my angles, okay? And so the very first one we see is a right triangle. To make it a right triangle, for it to be a right triangle, it has to have one right angle. And one of the reasons we know it can only have one right angle is because the angles in a triangle all have to add up to 180 degrees. If you have more than one right angle, because that's already 180 degrees, I won't have a third angle. And that also means if they've got to add up to 180, then one of them's already 90, the other two have to add up to 90. So the other two angles will have to be acute, and they're also going to be complementary. That's what it's called when it adds up to 90. I'll put in parentheses. Okay. All right. If it's a right triangle, notice that they are labeled A, B, and C. There's a particular rule that we will use a lot, and it only works with right triangles. We've already used it some in class when we dealt with distance formula. A squared plus B squared equals C squared. That's a Pythagorean theorem. Okay. The right triangle is one of the few types of triangles that also has special names for its sides. I've got to know that this longest side right here is the hypotenuse. And my other sides are both called legs. There's more than one place in geometry where we see parts of a figure that are called legs. Right triangles is only one place, and anytime we do, there'll always be two of them, which makes sense. We have two legs. So, and the next type of triangle is an acute triangle. If it's an acute triangle, it's going to have three different acute angles. All of them are acute. So if I look at my picture, every one of these has an angle that's less than 90, so they're all acute angles. I want you to think back what we just did on the right triangle. We said the hypotenuse was the greatest side. That's because it's across from my biggest angle. That 90-degree angle is the biggest. So in this picture, notice that my biggest angle here is 70 degrees. So across from it, we don't call it the hypotenuse. That's only in right triangles. But across from it will be my biggest side. Okay, so this is the biggest. That's just some good logic there. It doesn't want to let me write biggest here. Okay. All right. The last triangle based on its angles is an obtuse triangle. And an obtuse triangle is going to have one obtuse angle. So just kind of like we did with the right triangles, we know that all my angles have to add up to 180. So 20, 50, and 110 all add up to 180. And that means if one of them is obtuse, one of them is already bigger than 90, then the other two have to be acute. So it's a must. They won't be complementary this time, though. Okay. All right. So just like the biggest angle was across from, biggest side is across from the biggest angle, I can also say the smallest side, and this one's a pretty obvious one in this picture. This is clearly my shortest side. Notice that it's also across from the shortest angle, 20 degrees. This is the shortest. Okay. And we'll get a whole lot into that stuff a lot more later on, but that's just some things I wanted to point out that might be a little new. On the right side of your foldable, we have triangles classified by their sides. Okay, so on this first figure, it's an equilateral triangle, and the name kind of gives it away. It starts with equal. An equilateral triangle will have all three sides equal. So all sides congruent here. And notice that they're marked congruent. You see that little marking? And we've marked angles congruent. This is how you mark sides congruent, with a little bitty hash mark. So all those sides have the same marks. They're all congruent. And not only if all the sides are congruent, that also means all the angles have to be congruent. It's just the way they fit together. So if a triangle has to add up to 180 and all the angles are the same, then every equilateral triangle will have all 60-degree angles. So each angle equals 60 degrees. Which means every equilateral triangle is always acute. Can't be a right triangle, it can't be an obtuse triangle. Right? There's also one more name for an equilateral triangle. Because all the angles are the same, we can call it equiangular. It just means equal angles. That same relationship, how these matched up, follows through with every single triangle. Okay? So the next type of triangle that we have, notice all the sides are marked differently. I've got one with 1 mark, one with 2, one with 3. Okay, that type of triangle is called scalene, and scalene triangles have no congruent sides. So all 3 of them are different. And if all of the sides, if none of the sides are congruent, that also means that none of the angles are congruent. So no congruent angles. Every one of those angle measurements will have to be different. Okay, the last type of triangle we've got is an isosceles triangle. An isosceles triangle has the most information really to write about it. It's got names for its parts, just like the right triangle does. An isosceles triangle, I always used to tell my kids, and I'm going to draw some eyes here for funsies, that the way they could remember which one has the 2 equal is because isosceles starts with I, and you have 2 eyes. Okay, so it has 2 sides congruent. And if it has 2 sides congruent, it's going to also have 2 angles congruent. And those angles will always be the ones opposite my sides. Which are what is opposite the congruent sides. So if I look at this picture right here, see AB is congruent to BC, so if I look across from those congruent sides, I see those angles that are marked the same. So those are the 2 angles that are the same. The parts of an isosceles triangle, just like in the right triangle we had legs, we also have legs here too. So the 2 legs are the 2 that are the same. The one that is different is called the base. And it's all about that base, huh? It is called the base, and this top point, the one that is not the same, is called the vertex. These angles that are the same are called base angles. Okay, so those base angles are congruent. I'm going to write that out here because I don't think I have room there. Okay. That's basically it. So tomorrow when you get to class, make sure you have this foldable and you put it in your notebook. I'll tell you what page there. I don't have my list with me right now to be able to tell you the page number. And we will do some work with this, and we will look at triangles on a coordinate plane and classify them and throw some algebra in the mix and lots of fun stuff. So see you Friday.